In this question, an Atwood machine is constructed using two wheels with mass connected at rims. The left wheel has a mass of 1.8 kg and radius 20.01 centimeter. That means this wheel, the mass attached to this wheel is 1.8 kg and the radius is 20.01 centimeter. The right wheel has a mass of 2.8 kg. That means this m2 is equal to 2.8 kg and radius is 28.05 centimeter. The hanging mass on left is 1.55 kg. That means m3 is 1.55 kg and right is 1.27 kg. That means m4 is 1.27 kg. What is the acceleration of the system? Let me first write all the numbers. m1 is equal to 1.8 kg and r1, radius of this wheel is r1 is equal to 20.01 centimeter. m2 mass is equal to 2.8 kg and r2 is equal to 28.05 centimeter. m3 is equal to 1.55 kg, the hanging mass, and m4 is equal to 1.27 kg. So because this is a string, one tension force is working here, one tension force will work towards the wheel, and this, but the magnitude of the tension force will not be same because the mass is attached to the wheel. So let us assume the T, because in between these two tension there is no mass, so we can say both tensions are same, Tt. And for this wheel, because m3 is mass, so let us assume T3 the tension, and here T4 is the tension for force. And in the question the mass m3 is more, so we can say that m3 is moving, the string is moving downward in the direction of m3. So let us assume a is the acceleration, so this will go up with the similar acceleration. On m3 the weight force is working towards the ground, so m3 g is the weight force. For m4 also the weight force is m4z. Now if we will write the balancing equations, so first we will write the balancing equation for m1 mass. So for m1 mass, so this is because the object is moving in this direction, so we can write T3 R1 minus T R1 is equal to, because the wheel is do the rotational motion, so we can say that the force is working is equal to I alpha, torque. I is the moment of inertia and alpha is the angular acceleration. We know moment of inertia for the wheel m1 is m1 r1 whole square, and we also know the angular acceleration is related to linear acceleration as alpha is equal to a by r1. Let me write alpha is equal to a by r1. So when we simplify the RHS part, we get m1 a r1. In the whole equation r1 is common, so we can write T3 minus T is equal to m1 into a. Similar equation we can write for m2 mass. So for m2 mass we get T minus T4 is equal to m2a. This is equation number 1. This is equation number 2. For m3 the balancing equation is the m3 mass is moving downward with the acceleration a, so we can write F3 is equal to m3a is equal to m3g, force is more, so m3g minus t3. We can rewrite this equation as t3 minus minus T3 plus M3G is equal to M3A. For M4 mass, we get, because this is working upward, so F4 is equal to M4A is equal to, the tension force is more, so T4 minus M4G. We just interchange the LHS and RHS, so we get T4 minus M4G is equal to M4A. Equation number 4. So if we'll add up equation number 1 plus 2 plus 3 plus 4, that means LHS part separately and RHS part separately. So T's cancel out, T3 will cancel out, T4 will cancel out. Only M3G minus M4G is the remaining part. And in RHS, M1 plus M2 plus M3 plus M4 into A. So acceleration is equal to M3 minus M4 into G divided by M1 plus M2 plus M3 plus M4. If we put all the numbers, that means 1.55 minus 1.27 into 9.8 divided by 1.8 plus 2.8 plus 1.55 plus 1.27, and simplify all the numbers, then we get 0.3698 meter per second square as the acceleration for the system. So this is the answer. Answer is acceleration is equal to 0.3698 meter per second square, or we can write approximately equal to 0.37 meter per second square is the acceleration for the complete system. Thank you.